Greetings, chemists. What I want to do right now is just go through the notes on how to do stoichiometry calculations again with you. I thought maybe presenting them in another way, having another presenter might ring a bell with some more of you, and just having more problems shown to you might make stoichiometry calculations sink in a little bit more for you. So I just want to kind of go through some more of these stoichiometry calculations here with you. And I'm going to be doing this on my Surface, so sorry if my little picture is kind of weird down in the corner. But stoichiometry problems are just a mass and amount relationships between products and reactants. So I'm going to be switching between reactants and products. That's all I'm doing here in these problems is I start with product A and I want to react with product number C. And I'm switching between them two, okay? The big thing here is that we always start with a balanced chemical reaction. You can't do anything without having a balanced chemical reaction. And here's what I've got right here for us right now. This is called the Haber process of making ammonia, okay? Each coefficient, so the 4, the 5, the 4 again, and the 6, that is equal to a mole. So 4NH3 is equal to 4 moles of NH3. Okay. To determine the number of moles of O2 given 2.4 moles of NH3, you must carry out a mole-to-mole conversion. You are given the amount of moles of NH3, so NH3 should be in the denominator, and the conversion factor should include the amount of NH3 relative to O2, and that's what I have. So you start with what you are given in the problem. So I'm given 2.4 moles, and the 4 moles of NH3 came from that balanced equation, and the 5 moles came from that part of that equation. And now I've got my 3.0 moles of O2. And so I multiplied, I took 2.4, multiplied it by 5, and divided that by 4 to get 3.0. Remember to include units for all quantities. You can do mass, mole, mass mole, or mole or mass. Those are all types of things that you can do. If you start in mass, you must first convert to number of moles before using your mole ratio. The mole ratio is this thing right here, okay? That is what is called the mole ratio. It's where you have moles over moles. That is when we have the mole ratio, okay? That is when we convert between substances. That's how you do that. That's the mole ratio. That's what allows you to convert between substances. Okay? So the mole ratio is used to convert between amounts of moles. Mass, volume, and other quantities must be converted to moles first before the mole ratio can be used. So here's the mole ratio. Okay? Mole ratio. When you have moles of A to moles of B, okay? When you are converting between grams of A to moles of A, this is where you use the molar mass from the periodic table. The molar mass. So we'll write that over here. The molar mass comes from the periodic table. So have this thing handy when you're doing stoichiometry problems because you need it to do math problems. Okay. Steps to solving the problem. List what you know, set up the problem, calculate and verify. Okay, so we've got 2 problems that we're going to do here, and then that will be it for us for today. Okay, I got to put my little arrow here in my balanced reaction. It didn't carry over from the computer. Okay, so there's my balanced chemical equation. You always must have a balanced chemical equation whenever you start a stoichiometry problem. Okay, but it's asking how many grams of water must be added to allow 8.1 grams of magnesium to react. Now, what I like to do a lot of times is underneath the balanced chemical equation, write what I know and write what I have to solve for. So it's asking how many grams of water. So underneath the water, I like to put a question mark and a gram to let me know that that's what I have to solve for, and it has to be in grams. And then I know that I am starting with 8.1 grams of magnesium. So just by putting that there, I can kind of map out my problem, what I'm going to do there. So I kind of know what I have to do. So this problem is going to be a grams to mole, and then a mole to gram. Okay, so I'm going to start here with my 8.1 grams of magnesium. Grams of magnesium is going to go on the bottom, and moles of magnesium is going to go on top. When I'm working with grams and moles, mole is always going to be a 1 when I'm working with the gram. And then, drop my pen, periodic table, magnesium is 24.31. So 24.31 is magnesium. Now I can do my mole ratio. So I've got moles of magnesium to moles of water, because that's where I'm going to. And I'm doing this so that my units cancel out. Okay. And so magnesium has no coefficient in front of it. So that means it has a 1. And water has a coefficient of 2 out in front. So we're going to put 2 there. And then we're going to go one more step out and do moles of H2O to grams of H2O. And again, when you're working with grams and moles, moles gets the 1. And then water is when you add up all the masses of water, it is 18.02. And then I'm going to come to my calculator, and I'm going to do my math here. 1 divided by, and we are going to get 12 grams of H2O as our final answer. And there we go. So there we go. There's that problem. Okay. Next problem. How many moles of iron? So over in iron, it's going to be a question mark because I'm looking for iron, and I'm looking for moles. So I only have to go to moles in this problem. I don't have to go all the way to grams. Okay, and it says we start out from 128 grams of aluminum. Okay, so here we go. And there's an arrow where this box is. Just didn't carry over. All right, so we're going to start off with our 128 grams of our aluminum. Grams of aluminum going to moles of aluminum. Mole is going to get the 1 with going from grams to moles. And then periodic table time, aluminum is 26.98. Now we can do our mole ratio, moles of aluminum. And I'm doing that so moles of aluminum crosses off, going to moles of iron. And I have 2 moles of aluminum to 3 moles of iron. Okay. Now, the question is asking for our final answer to be in moles, and I am in moles. So I don't need to go any further. I can stop right there because I'm in the desired unit. Okay, so calculator time, 128 times 3 divided by 26.98 divided by 2 will give us 7.12. 7.12 moles of iron. And there we go. So those are some stoichiometry problems for you, just in another way presented to you, doing the same processes as the other ones that were presented to you, just maybe explained in a little different way, and maybe some of you will relate to this explanation a little bit better or whatever, or maybe the other ways spoke to you a little bit better, whatever. I just wanted to present another way of explaining how to do some of these stoichiometry calculations for you. But that's all that I wanted to do for you today, is just to go through these stoichiometry calculations with you. So you're going to get some more practice with these. I wish you the best of luck. We can talk about them up on Thursday a little bit before your test. You do have a test on Thursday, but we can talk a little bit before the test if you have any specific questions that you would like me to address. So good luck, and there we go.